Welcome everyone to the second day of the conference. Today we will have much more work to do because we have a full day of presentations and sessions. I am now very glad to introduce our good friends and partners from the Silesian University of Technology, Professor Zbigniew Marszalek and David Pollard, who will present a tutorial on the efficiency of computing by the use of modern architectures, the case of Internet of Things and big data sorting. Please go.
Thank you. So I will start. The basic question is, what is Internet of Things? So I believe the first word, Internet, everyone knows. So it was created by people for people. So we all update some information into Internet, like videos, music, and every document we have. For example, some articles from this conference will be online available on Internet. So we produce data and collect them in Internet. So we can say that it is Internet of people, because people update information and collect them. So when we say Internet of Things, we may say that things collect data, process them, and exchange using the Internet. That's why it is Internet of Things. Okay, so basic example of that can be our smartphone. Everyone knows what is it. I believe everyone has it in this conference room. It has some built-in sensors like camera, microphone, and some others one. Okay, so people, when they are in some environment, they are collecting data. For example, when we look at something, we use our eyes to see them. We can write them and update to Internet. Things can also do the same things. For example, using the camera, we can record some video, take some pictures, and then update to the Internet. And these things, these equipments or the devices can do and communicate between them using the Internet. Okay, so the basic elements of the Internet of Things by some technical side can be application and user interaction. When we say application, our Internet of Things, our equipment can communicate, but for example, when they collect the data, they have to process them and give us some result. For example, in our home, we may have some cameras, some motion controllers, sensors, that can collect data, for example, images, process them, found some persons, and give us information when we are in another, for example, state or country. Okay, another one is cloud server, because when we collect data, we have to store them in some place. An example of that can be local database, which is located in our homes, but there could be some accident and our database will be destroyed. That's why we need to make some copy and put it another place. For example, it's cloud. Another example is network and gateway. This is the parts that are used to communicate these physical devices, and that's why the most important thing in Internet of Things is physical devices that are connected to the Internet and use it to communicate between them and exchange some information. Moving forward, the basic elements of the Internet of Things of every equipment, every devices, is sensors. These are built-in sensors that could be understood as some sense that could exchange, obtain some information from our natural environment. For example, our smartphone has microphone. It can be some ears for our equipment to record voice, to understand people, to understand another sound, another speech, another everything. Another one is camera. That is used as our eye. Another one can be motion sensor. That could make and understand where some other devices is located in our room, for example. Another one is speedometers that knows when our for example, this smartphone is moved, and it knows what is the speed of them. Another one is heat sensor, which sensor knows what temperature is in our environment. Okay, so the most basic equipment of that is smartphones. Another one could be some built-in camera sensors that use it in some intelligent homes. Okay, so what is the basic information flow diagram in our system that uses Internet of Things? At the beginning, every device has some sensors. It collects data and sends them to some local server. At this local server, there is some processing data and some merge information. This merge is important because when you have some sensors, they could obtain data in different way about one situation, about one thing. And that's why we need some merge and after that make some decision if it's important thing or not. And example, when we have our smartphone and it's record some wall, for example by 5 hours, the important things will be only in first second, in first frame, because the next 100 frames will be the same. That's why the decision module is important in this local server. All this important information after accept decision is located on our local database. It's important to make some copy and update information to global one in the case of an accident. That's why we have some cloud information and some exchange data with external database. Going further, all these obtaining data are stored in our local and global databases. It is important to find this information. For example, when we collect data through years, there will be a lot of them. So we need to collect only one. How to do it and how to, in fast way, find this information. And it is quite simply because we need to create some efficient algorithms to sort and search this information in databases. And this part will take my friend. Okay.
No SQL databases, you need to create your own way to search for information. The existing way is to sort of big data and apply binary search. No SQL database have gained important and currently stored in them amount of information exceeds the effective use of SQL engine. Merge sort. One of the most appropriate method for serializing information in a database NoSQL is the merge sort algorithm. In the literature, we can find many versions of this algorithm. Let us suppose we have a sequence of number A. We can sort it by dividing into subsequence, then merging sorting subsequence. Double merge procedure is the first step, begins with comparisons of pairs of input sequence. In this way, as a result of the first step, we obtain two component stacks. In second step, we merge received from previous step strings. As a result of this operation, we obtain stacks containing double number of elements. We merge until we have only one stack. If initial sequence contains an odd number of items, we retrieve last element until last step in the algorithm. In the last step, we merge it and get a completely sorted input. Merge two strings. It is very new algorithm. We have two sequences, X and Y, and return in this algorithm one sequence having 2m-1 comparisons, maximum comparisons. For instance, we can show this merge two strings. For instance, we have in this moment two sequences, 6, 8, -1, 7, and we compare 6 and -1. the -1 is going to output sequence. In next steps we compare 6 and 7, and 6 is going to output strings. In next step we are compare 8 and 7. 7 is going to output 7, and last 8 is going to the output sequence. No recursive merge sort merges elements in pairs without division. First elements are merged in pairs, then in fours, and so on. Continuing to do so, in each step we got organized double stacks. If n is not power of 2, merging contains leaving at the end odd elements. It will be merged in last step, as shown in figure. We can see how the merge works. We see the input string. Next we compare one elements, next double, and so on, and it is sorted string. No recursive merge sort, it is in diagram. It is very easy to implementation. Increase the number of merge elements items 2 in each step until we obtain n. Then we stop. It's very simple algorithm. Theorem. Merge sort algorithm has time complexity, time max, and the logarithm at the base of 2 of the n minus n plus 1. It is very important. Here is recursive merge sort. We see that in recursive merge sort a binary division was used to share over 2 strings. Sharing is performed until we got 2 strings of single elements. Then the algorithm merges and passes them to the second division as consecutive subsequence for merging. So it is the first step. Next we begin to merge strings. Here is the comparison of time complexity. We see the no recursive merge is 16% quicker than recursive. So it is much more better, no recursive. It is always the question if recursive is better or not. Parallel random access machine. Of course, we now use many processors, so how it works, it is seen here. We have many processor memory, and we can divide our process of merging in our machine. What is machine model? Describe a machine, put a value of the operation on the machine. Why do we need a model? In a simple way to design algorithms, achieve complexity bounds, analysis maximum parallelism. Very low random access machine, unbounded number of local memory cells. Each memory cell can hold an integer of unbounded size. Instruction set included simple operation. All operations take unit time. Time complexity, number of instructions executed. Space complexity, number of memory cells used. Prem random access machine. Definition is an abstract machine for designing the algorithm applicable on parallel computers. Machine is a system PAM, computer processor, instruction for each the processor, memory to which all processors have access. Our computers now are in this way. 2 or more processors may read simultaneously from the same cells. A write conflict occurs when 2 or more processors try to write simultaneously into the same cell. Params are classified based on their read-write abilities. Exclusive read, exclusive write. Every memory cell can be read or write to be only one processor at a time. Concurrent read, exclusive write. Multiple processors can read a memory cell, but only one can write at a time. Exclusive read, concurrent write. Never consider concurrent read, concurrent write. Multiple processors can read and write QPRIM is sometimes called a concurrent random access machine. Definition: time complexity. The time complexity of the algorithm run on the PRIM machine can be defined as a time number of instructions of the longest proceeding processor during the execution of the algorithm. Definition 2. The memory complexity is the number of cells used by the PRIM machine to perform the algorithm. And definition 3. The processor complexity is the maximum number of active processors during computations. The presented calculation model adequately determines the operation time of the algorithm of a computer, which performs the entire in the operating memory. For analysis of external algorithms, other calculation models are used. No remote memory access or uniform memory access. Now, here is the question. Is such computer on which is machine PRIM? Now we can find the firm Oracle, and we see they have such computers, and maybe a little about Oracle computers. Spark M8 processor. We see below computers with 1 processor, 2 processors, 4, 8, and 16 processors. We see it's a very powerful processor. We can see how it works. Spark M8, 5 GHz, 32 cores, 8 threads. In fact, 256 logical processors, 1 chipset. And for more, this chipset, this chipset has supervisory processor, 1 more, who control processors, 256 processors. If application try to call thread by thread, he stop them and pull down to 1 processor. Here is the figure which shows how the 8 processors are connected together here, and here is how 16 processor is connected together with switch. So such machine, in fact, we see it's 4,000 processor in 1 chipset, in 1 computer. So you know how cloud is working. So we can show how simple algorithm is working on PRIM machine. For instance, how to find the largest number of n numbers residing in memory location. Serial algorithm is complexity n. PRIM algorithm use n second processor is the logarithm at the base of 2 of the n. And it is as one of these algorithms how to use it. We have memory here, yes. In memory we can processor P0 in step 1, processor P0, find the maximum of M0, M1 and save it in M0. Processor P1 find the maximum of M2 and 3 and save it into memory 2. Processor 2 maximum from M4 and 5 and save it in M4. Processor 3 maximum from M6 and 7 to M6. In next steps only 2 processor is needed because only 4 elements we have, and P0 maximum from M0 M2 to M0, P1 maximum from M4 M6 to M4, and now it's only 2 elements to compare, and 1 processor is needed to compare the elements. Simple algorithm, logarithm at the base of 2. Quantum algorithm and Grover algorithm. The algorithm applies to the database searching contains of n elements in order to find the highlighted item. This is a problem that is similar to receive searching the phone book. In the book containing the m data, we want to find the number holder. As far as the number of steps necessary to resolve the problem by using the classical algorithm is over of an ethics show before. Grover algorithm has the square root of n steps. To solve it is the by unitary transformations used in this moment, but we try to find out which is better, to use the Pram machine or to use the quantum machine. In fact, if you go to the internet, you find that quantum is better, but it is not true. We will see. If we want to find element in sequence, we can sort it. Match sort, parallel match sort, have logarithm at the base of 2 square. It is the algorithm which is used of algorithm of Pram. If we want to find element in sorted strings, we can use only logarithm at the base of 2L compilers. If we use quantum machine, we have the square root of n. We will see, for not too big, of course, quantum is quicker. But if we have 100 million elements, Pram is quicker than quantum. So it is maybe amazing, but sometimes old computers are better. It is the question, how much longer will apply Moore's law? In the field of artificial intelligence based for division speculation, Moore's law. Gordon Moore was Intel's co-founder, law creator who noticed the trend in the development of computer technology. The number of transistors in a chip doubles at regular interval about every 2 years. From 1965, the year, the rate it works, all the time. Gordon Moore predicted, among other things, the rise of mobile phones and the personal computer. Progress in the field of construction of CPU can be seen in the products offered by Intel and Oracle. Available on market is currently Oracle processor M8 with 32 cores and 256 threads, made in technology 2 nanometers. Growth in recent years is visible on the slide presented by Oracle. Here we see how is computer growth in recent years. How much longer we apply Moore's law? Recently ago, Intel unveiled the computer of a plurality of pen drive 10 nanometers technology. The computer was based on the Atom processor with HDMI on the one hand and the USB connector on the other. Currently, Intel conducts research on processor made in the technology 5 nanometers. Oracle announced they received a computer with 124 cores, 8,192 threads, and 64 TB of RAM. It is clear, however, the Moore's law may not be valid forever. The limits seem to be performed processor in technology 5 nanometers. With the information provided by the companies about the planning development next generation processor, so the Moore's law will still take effect on over next 10 years. Thank you.
Any questions? Questions? I think there was one kind of architectures like exclusive concurrent which you were not considering. Why?
I think the Oracle is now more firm, which is more on the top. In fact, he has much powerful computers in the world. Nobody in the world has such computer like Oracle. It is a problem, but Intel is very good, but it isn't as good as Oracle.
Any more questions? So thank you for your presentation. And here is the certificate of participation for you. And also for David. Okay. Thank you very much.
Thank you.
I think we now have a coffee break and then we will start with the regular session.
Yeah. Okay. So we had a discussion already before, so it doesn't matter. We have at the moment 1 hour time for 2 presentations. My proposal would be to have 20 minutes and then a long discussion about it, because both topics are very interesting. And we are starting with the first one, which is in the medical field, and this is rate your physician. And who has no physician and want to rate him? Findings from a Lithuanian physician rating website, and presentation is done by Joska Kersting, and he has also the second author, Frederick Bäumer. The other both authors are not here, it's a pity, but okay. So let's see what we can do and how we can discuss your presentation. Please start.
Thanks.
But what I have to say is this is a more or less German session at the moment. So I'm from Germany, the authors are from Germany, from the first and second paper, so this is a nice idea to have really some contact here and to see how the contact from Germany to Lithuania and to Lithuanian colleagues are running. Please go
Thanks.
ahead.
Thanks for having me here. I'm going to talk about the Lithuanian physician rating website. It's called ICIST2018. And as you can read, I've got one Lithuanian author in our team. He helped us translating the Lithuanian language ratings. So, rate your physician, it's a global phenomenon. Like, every country has its own portal website or several websites for rating one's own physician. And so far, the reviews have been extensively researched, oftentimes by doctors themselves. Part was by computer scientists and computational linguists. The ratings usually are very positive or negative, but oftentimes very positive, like in all rating websites. And the thing is, they affect the sensitive physician and patient relationship because, yeah, of course, usually you want to trust your physician and you want to be treated well. But with ratings, they're semi-anonymous afterwards given for one physician, put this relationship in danger. And oftentimes people reveal too much about themselves, and they can be recognized by the physician, for example, or by neighbors or friends. So why is this important? The websites affect significantly the success of a physician. So this is in the end effect about money and reputation, and oftentimes patients use them to base their decision on them. So they choose a physician based on reviews. And as I said, the privacy is in danger, even for the physicians. There are a lot of lawsuits in Germany done because of physician reviews. Some physicians felt treated unfairly, or they don't want to be rated at all. So it's a big issue in Germany, at least. The thing is, the websites do not check the identity of people, so they don't ask for the passport or something. They do not check, was this person really at this position at some time. And in the German case, there are two websites, Yameda and Dog Insider. On Dog Insider, we had the thing of a problem. The source code wasn't really well written, and we found a little hack. So it was possible to change one parameter, and then we could answer to a review in the name of a physician. This is, of course, legally highly problematic. I will later on show a little video for this. Just to give an overview, we have so far researched several rating websites across Europe and the USA. As I said, in Germany, there are Yameda and Dog Insider. Now we are dealing with Lithuania's Pincetas. Furthermore, we have researched websites from Austria, Switzerland, Spain, and the USA. So why do we do this? It helps us to find good and bad characteristics of this website, and we want to have or develop a quality understanding. So what makes a good website, what helps people preserve their privacy, what helps a physician to receive useful feedback and fair feedback. So what we do is we analyze the data set with natural language processing techniques. We want to find out which data quality we have and are there fake data, for example. Furthermore, we want to have a brief look on rating websites or health-related websites in Lithuania at all, because we want to underline the aspect that physician review websites are very unique when it comes to the user interaction. Most websites don't have this interaction component. So this is the little video I will show just briefly on Germany's DocInsider.de how to do this little trick with answering in the name of a physician to a review. At first we briefly show how many physicians are there on the portal. I think it's not really well readable, but it's about 60,000. And you can even crawl the website by using a star in the query, so over 320,000 physicians. So if you then open a physician's website, it looks like this: accumulated overall ratings and single reviews. Then the trick starts with opening the source code of a website. You can do this with any web browser like Firefox. You can read it now, but the source code uses variables like Peter Pan, Peter Pan, Peter Pan. So it's not very professional. The dog is mad bro is another variable. So I think this is the one for answering. If you delete one word, you see, you get a new text field. We there write thanks in German. And click on save. And then it says, on the 2nd of some day, Dr. so-and-so wrote thank you. So we could even write it's a word weight insults in the name of another person, for doctor for example. This is of course problematic. So if we move deeper into our study, our dataset is the Lithuanian physician review website. So far, data from Central and Northern and Eastern Europe have not been researched well, except for Germany. We got this idea on last year's ICIST, and we found a Lithuanian researcher helping us with translating. Of course, the goal is a little data analysis and using location data. I'm saying something to this later on, and a fake analysis. Thing is, location data. Pincetas is different from other websites because it displays the IP address of the user who has rated a physician if this person was not logged in. And oftentimes it's the case they display the IP address. So other physician review websites don't do this. We want to visualize them to make some new findings, and yeah. Is there maybe a problem with review fraud or fakes, or what is going on? So what's the natural language processing? As I said before, in Lithuania there are several websites we have categorized here, and they all deal with healthcare and lifestyle, health-related lifestyle, but in the end there's only one physician review website, and yeah, only 2 websites with strong participation. I think this second from the ground level something like a forum. So it's quite unique that users engage in a website this much. Pincetas, when it comes to our data, has a strong increase since the year of 2016. We collected the data by the end of last year and beginning of this year. For example, in the year of 2017, there were 13,000 new reviews. There are around 57,000 healthcare providers and roughly 3,000 hospitals, and over 80,000 reviews in total. The first is from 2006 already. About 3/4, so 74% are positive of the reviews and 26% negative. There are 78 specialist areas. And the three most represent are general nursing, physician, or odontology. And there are licenses in Lithuania, and 85% of the profiles contain them. So they state which licenses this physician has. The healthcare providers, the physicians, are assigned to oftentimes one medical institution. Some are related to 2 or 3, and only a few to more than 3. So they are practically working in 3 hospitals or 4 at a time. But in most cases, this information is just missing. So we assumed they've got their own little firm, maybe. There are several rating categories, for example, diagnosis, question answering, how much time was used. So far, only 12% of the healthcare providers have been rated, but there are over 160,000 recommendations, so that's only half of them. I said over 80,000 reviews, and there are 80,000 more reviews without text, so only giving grades. Yeah, and down here we've got a little review example. We translated it to English. As you can see, here's the IP address given. We, due to privacy reasons, made this black box here. And you can see here what the physician can answer, like on the German portal. The reviews are rather light, because in Lithuania, on this website, you cannot see the single grades for every category. On the German website, you were able to see every grade given. Here you see only the text, and the grades are accumulated in an overall rating. You don't see them. Yeah, the website tries to fight fake reviews, because, for example, some doctors, the profile says, okay, 23 textual reviews, and if you count them, there are only 20. So maybe they have deleted 3 reviews, or taking care of them, checking whether they are fake. Yeah, in this case, for 23 reviews, the healthcare provider was rated very negatively, so maybe it was just spam, fraud. Yeah, and Pinsetters uses a few anti-spam measures like captchas. So rather standard. Here we've got listed our rating dimensions. In fact, they are comparable to other websites, like in Germany. Some other websites across Europe only use one word, like diagnosis. Here you've got a full question. So like, were all your questions answered? I think this leaves less room for speculation or for interpretation. How long did you wait for the appointment? And as you can see, overall the grades are rather very positive. And yeah, except for was there a follow-up contact, most of the dimensions were rated over 11,000 times. So yeah, we've got the average grades for different specializations of physicians. As you can see, some are better rated than others. Neurologists are not well weighted, but odontologists, one of the most used specialization, is well weighted. This slide is quite important because we checked for fakes using natural language processing. For example, Just a little finding, the negative reviews were much longer than the positive ones, like twice the size. And then we used n-gram analysis, and the most common sentiment words in positive reviews are like thanks, great, nice, translated of course. And the negative reviews, they are very unpleasant, nothing good, not recommended. We split all reviews in sentences, so as you can see, every review has roughly 2 sentences, but only 96.5% of these sentences are unique. 3.5% were full copies, and we made a network analysis like over there, connecting on the sentences to all reviews we were in. And so, yeah, how to say that? It is possible that some people copied just reviews. Thing is, it looked like some sentences were just stick together randomly and posted in several reviews. So like a systematic fraud, but you don't know why this happened. Maybe the portal itself did this. Maybe some people wanted to increase their own rating, the rating of friends. It's hard to say, it's just our finding. So we had this case in Germany where the Doc Insider, the website I showed in the video, just copied full text reviews from the bigger website which is called Yameda. So that was a real fraud, and they got sued and lost. I don't know what's going on here. We used the IP addresses to find out where are the people located. As you can see, a hotspot is of course Lithuania, but they are in a lot of other places when they rate their doctor or their physician. This somehow fits to the common immigration locations of people from Lithuania, so they maybe rate their doctor from their new temporary home, maybe like England or Scandinavia. And on the other hand, it's possible that this is caused by fraud, because people in other countries are for some reason posting reviews and frauding the website. We used the locations of the physicians to show where they are located at. This again reflects the city size in the end effect. For example, Vilnius as the biggest city in Lithuania, there seem to be the most physicians, in Kauna second biggest, second most, in Klaipėda third biggest, third most. And some other cities are covered as well. So, as we can see, this physician review website is truly comparable to physician review websites from other countries, even to the bigger ones like RateMDs from the USA. But it has some extra features like showing the IP address. I think this is very good if you want to prevent some fake or spam, because it's obvious. But according to the new data protection law, this may be problematic, showing the IP address, and there is possible review fraud. It doesn't have to be, but it might be. Of course, we have several findings. I mentioned before, the reviews are overwhelmingly positive. The negative reviews are twice as long as the positive ones. The people maybe go to a doctor at home here and rate them from their new possible temporary immigration home, like London. And on German portal Yameda.de was the case that only 2% of the reviews were quantitative only, so only grades, no text. On this website we have like half of them are only grades, no text. And this is my presentation, so thank you very much. I'm here for your questions.
Good, we have some time for questions.
Was this problem that you showed in your video solved? Or is it still possible to
they didn't react to our mails for a long, long time,
okay.
like 2 years, and then the company went out of business and was bought by another bigger one, and then they changed the whole setting of the website. So when it was solved, but no one ever answered our mails.
Yeah, from my point of view, we have different healthcare systems in Europe. Does some of the system components or strategies are reflected in the ratings? Like in Germany, we have private patients and private paying patients.
Here we weren't able to collect. There was another category, rating category, and it said like, did you pay extra money? And we couldn't collect it because you had to be logged in. But yeah, in the end, it was reflected because, yeah, as I read, at least, people often have to pay an extra cash money for getting an appointment soon.
Oh, yeah. Yeah, what is the future of your research?
As we are planning, we want to develop some system, or it's my personal project, for different rating portals across Europe. And the system should recognize automatically from the text the categories that are rated and how they are rated. And I want to get away from the rating schemes you have. Oftentimes you have stars, like 5 stars is the best, but sometimes you have school grades, 1 is the best, and so on. And my system should, yeah, find a solution to this.
How do you deal with the different cultures in ratings? So some people are enthusiastic if they are rating something are very, let's say, rational or more pessimistic. And there's also waves. Sometimes there is a media wave that everybody in the medical domain is doing fraud. Sometimes they are the saviors, whatever. Yeah. So there's also different types of bias, I would say. Do you deal with this?
So far not, obviously. But it's a thing we have in mind, at least. For example, the American website is quite different from the German one, even though the categories are the same. But people write much more positive, so they exaggerate. And Germans are like, yeah, it was okay.
Yeah,
so,
which is already the big plus then.
Yeah, big plus.
As you used NLP for this, and your group is semantic orientation.
Yeah.
So what is, because I think the people are educated differently. So some know a little bit about their reading internet about their disease. Is there any big difference between the people in cities, rural areas, or well-educated, not so well-educated? Do you have information about that?
Obviously, we didn't find big differences because it seems like people oftentimes go to physicians in big cities. So it's not a big difference between cities and rural areas because everyone goes to cities because of the physicians.
Yeah, so let's see what next results are. I think it's nice to have it here. It's nice to have in comparison the German way, but there might be, of course, other ways which are very important. And how far can you, with your NLP, analyze different languages? This is, I think, a problem. If you have people here in Lithuania, I don't understand mostly no words in Lithuanian. And is it possible for your colleague who was in this paper to analyze it through special tools for NLP?
I think the cover of NLP tools is oftentimes, or the coverage is oftentimes for the bigger languages, like of course English and maybe German, French, and in Lithuanian. As far as I know, we don't have that. So we used his knowledge. He speaks German, Lithuanian, and English to translate that. And
good. Yeah. So let's see, and hope that you will come again next year and with some report about some progress.
Thanks.
And we'll start with the second part.
Okay. Thank you.
Thanks.
I like, by the way, that some of the research was initiated at another ICIST conference, so that is the intention, so to foster cooperation. So yeah, the next presentation is quite different. It's about an architecture, software architecture. Yeah, so it's called Design of an Operator Controller-Based Distributed Robotics System. Has nothing to do, no, something to do maybe with health. We will see. Oh, yeah, we are waiting.
Password.
Oh, yeah.
Okay.
signal.
Yeah, the computer is on, but password required.
German session. And by the way, only 130 kilometers away from Paderborn University, so close by. And Jan is based in a research institute of digital transformation. Yeah. So now we have
It's working.
slides. So then, please, it's your floor.
Okay, thank you, Carsten. So my name is Jan, and I will talk to you about design of an operator-controller-based distributed robotic system. So first of all, the agenda, short introduction to my topic, concept and architecture of the distributed system, and then I will present to you a robot that we built, and with a conclusion and outlook. So first of all, short introduction, and I would like to talk to you about the complexity of mobile robots. So, as you probably know, mobile robotic systems are complex technical systems whose design and advancement is a challenge for developers. So, you have that's both for hardware sides and software sides, because in mobile robots you have extensive functions as well as a high number of actuators and sensors. So maybe you know the narrow human robot, it has about 90 sensors and actuators in a small mobile robot. And when we talk about mobile robots, we always have in mind that they are acting autonomously, and autonomously acting robots need powerful hardware to perform complex software algorithms. So, for example, running a particle filter mobile on the locally on the mobile robot must be possible. Yeah, distributed and modular design approach. So, in the past, you've often seen robots that used one computer as a processing unit. So, if you think of the first examples of the demonstrators of the robot operating system ROS, we had this robot that always had a computer on it, like a laptop. But with embedded systems like single-board computers, so single-board computers are like Raspberry Pi or Arduino boards, these embedded systems are more energy efficient and more suitable for processing units on a mobile robots due to its size and the energy efficiency. So, but when we think about the complexity of robots, maybe it's not enough to have one single board computer. We have to use multiple ones to obtain more computing power. So what we're doing is we combine multiple single board computer to a distributed system within one robot. So we are not talking about a distributed system with 2 robots or 3 or whatever. We're talking about a distributed system within one robot. And when we distribute our system itself, we have to create interfaces between the single board computers and the models. So we are working in a modular way, and the modular approach itself is very good to extend your robot for specific tasks or something like this. So one example is a Miro robot from our partner university in Bielefeld, which is a small mobile robot with a modular approach. Okay, so and one obvious reason to use more than one processing unit on a robot is that you're not depending on one processing unit. You can solve problems that maybe are not able to solve with one processing unit. What I'm doing, or we are doing in our research, we concentrate on the architecture that we are using within our distributed system. So in the past, there always were distributed systems within a robot or a technical system, but often the architecture has grown historically. So, for example, you had a Raspberry Pi on it, then an Arduino was added to the system or something like this. But this often had the problem that you mix real-time tasks with comfort features, for example, and this is normally not a good thing, even for or at least for robotics or autonomous vehicles. So we are concentrating on how to design distributed system architecture and how to integrate real-time autonomy comfort features in such architecture. So let's talk about the concepts and architecture of the distributed system that we built. So first of all, I want to show you this picture from a book called General Technology, something like this, from the 1980s, from Mr. Ropol. In his book, he showed this activity system, which is layered in different layers. So we have the bottom layer where we have the execution system and information system above, and what is clearly outlined is that we have material only working with the execution system, and information then in the layers above. So we have a structured design. Later then, in about 2000, there was invented this operator controller module from actually from the University of Paderborn, which uses the same concept. So at least it is structured in two parts. So we have the controller part, which is our execution system. This one, the controllers are connected to our sensors and to our actuators, so to our physical system. So the controllers itself control our physical system, and the operator, the brain above, controls then the controller, but not the physical system itself. So what we can do here is we can divide in hard real-time that we need with the controller and softer real-time in the operator part. So we are using this concept that was invented for a mechatronic system like a rail cab in robotics now. So same picture, but that should show that we have on the controllers itself, we have not this high computing power. But when you think about the operator, which then is used to run tasks or something like what the robot actually is doing, then we need higher complexity. And we can divide our system in an action level, which is the controller part, which needs hard real-time, and a planning level with soft real-time that I already mentioned. So the concept summarized, we have a hierarchically layered architecture with time discrete versus event-driven patterns. So time discrete obviously with the controllers, and event-driven with the operator. So the controllers, for example, needs to stop immediately in case of emergency. So we have hard real-time and time discrete functionality. And the operators are responding to events from the controller, so they are event-driven. That's why we use model-based development in our system for the operator, because this event-driven engineering approach is, of course, very suitable for model-based principles like state charts or something like this. Okay, so then next, the design of our robot, which is a demonstrator for the architecture I just showed you, is called DAE-Bot. It's a distributed architecture evaluation robot, and the DAE-Bot is developed to evaluate distributed architecture within one robot. So we are testing this OCM approach and other ones evaluate it. So we are using a modular design, and especially we are using only single board computers that are widely available, so that promises to make the design of different modules of the robot very easy. So for example, we are using typical Arduino boards or Raspberry Pis that we can give to our students. They can work with it very easy, and then we bring everything together to build the bigger robot. Yeah, that's the actual design of the robot, so the modules. So, whoops, in the middle we have the controller parts. We have a so-called health controller, which I will talk to you about later. But first, the internal robot controller is some kind of, every robot has this controller, like reading the motor encoders, driving the motors itself. This one has the ultrasonic sensors attached, and internal sensors from the board. So this is an STM32F3 Discovery. Then we had a cam controller to get vision, so computer vision parts in it, like we have an RGB camera on it and the depth cam. And what we also have is, so that's a Raspberry Pi, we have an Arduino Mega on it, which is the so-called health controller. The health controller is not in terms of health like we heard in the first presentation, but in terms of health of our technical system, like how are the temperatures, there are temperature sensors, how is the power consumption, how is the CPU usage, something like this. So this is done by the health controller, has some bigger extensions like a relay board. So the health controller, for example, is able to start and shut down every component of our system. And above it we have our operator, which currently is a Raspberry Pi. Yeah, the operator itself then gets all the information from the controllers and acts to this. And what we can do with the relay board, for example, is that we have here an RGB cam and a depth cam on the cam controller, and we can decide, or the operator can decide, which of both we are using. So if we have a lot of lights and maybe we don't need to use the depth camera, so we can shut it down with the health controller for higher energy efficiency, or we can turn it on again. Yeah, then we have another operator, which is an FPGA board. So that's the idea of this modular approach, that we can add specific hardware for specific tasks. So for this example, we are using an FPGA board to run our OpenCV algorithms, as they are working much more efficient on a FPGA board than on a Raspberry Pi. Yeah, all this is connected via CAN. So our communications is done with controller area network. What I did forget to mention is that the idea of this demonstrator is to use many different evaluation boards. So we have a Raspberry Pi, which is another type than the STM32, for example. So we wanted to combine one of every of many areas. So the communications, we are via CAN. We developed the self-developed publisher-subscribers concept. You probably know from robotic operating system, for example, from ROS. So what we can do, we can alter the sample rate of our subscribers, for example. So we use the concept from a robot operating system and use it for ourselves and extend it a little bit. We use our own CAN frame IDs. So normally you have 11-bit CAN ID, and we split it into identity, which is normal, priority, and another so-called command or sensor bit, so that we can alter the priority directly in our identity, which makes sense for using hard real-time, for example, and to decouple motor driver codes from OpenCV codes, for example. Programming languages and methods we are using. So when you think about the controllers, they need to run hard real time, so they should be as efficient as possible. So we used about 95% of C and a little bit of C++. But these controllers are all only developed once. So if the controller is implemented, then it will never change. It will reconfigure, but it will not change. And the operator itself will change from task to task, whatever the robot should do. So we are using MATLAB Simulink Stateflow there, which is a model-based tool for state charts, and you should probably know it. What else we can do with this MATLAB Simulink Stateflow approach is we can simulate our behavior of our robotic system in advance. So we can give some dump CAN messages in there and check our system before we load it actually to the robot. And what I mentioned at the very beginning is that using a distributed system within our robot is helpful for safety reasons, because we don't use one single processing unit where everything depends on. So what we are doing, every module of our robot has some safety features, like simple ones, a local watchdog that just checks if the connection is still working to the operator. And for example, when the internal robot controller, which runs the motors, detects that the connection to the operator breaks down, then it just freezes the motor, so that nothing could ever happen. And it's also possible then to restart the operator in case it breaks down with the health controller. So this is how the robot actually looks like. So the idea of it is that we have this layered structure from the operator controller module in the demonstrator itself. So we have the internal robot controller here, the health controller here, which is pretty big because of the relays, and on top, which you can see here, we have the operator part, which then is added with Raspberry Pi display for visualization features. So the demonstrator itself is a demonstrator for the architecture. Okay, so conclusion and outlook. We successfully implemented the operator controller module on our self-developed DAE bot, and the decentralized approach is useful, for example, to design scalable robot platforms which can easily be extended, like I showed with the FPGA approach. The operator controller module architecture is helpful in robotics, for example, to decouple time-critical functions from non-time critical functions like visualization. And the project is still running, and we are currently working on another layer above the operator, which is called cognitive operator, for self-optimization features, so that the robot can optimize itself. I'm done. Thanks.
Then the floor is open for questions. Anybody who has questions about this? Yes, please.
Yes, about controller area bus. Have you looked at the other designs like that when you develop your controller area bus?
Yeah, we use the typical approach that is used.
Yeah, but I mean, you mentioned that your format of the
normally
is some kind of unique.
We alter this. Typically, you have just an identifier in the start of your CAN frame, which just is just the identity. But we alter it and add some priority in it. That's typically so you have a priority like a lower number of this identity has always a higher priority than a higher number. The other way around. But we added this priority bits in there to have a more precise priority to use it. For example, the controllers itself can change the priority to make clear that something's happening that is unusual. So it changes the priority, and this is detected, and there's already going something on with it.
And for priority, you have only 2 bits, which allows only 4 different categories, right?
Yes, but it's enough.
It's enough, right?
Yeah, for now it's enough. You have just like for motor drivers, you have a high priority, and for, I don't know, visualization tools, you have the lowest one. That's what we do there.
So, more questions? I have maybe an additional question adding to your question. So, meaning if you are using the identifier, that can identify as a priority, that it is fixed for the whole lifetime of the system, because it can identify
Yes.
is fixed, and now you have a dynamic
Yes.
aspect, so you can change while in operation. You can change priorities.
Yeah, as for example, the ultrasonic sensors run with a medium priority, and then when you hit an obstacle, the priority rises, and that's another hint for the operator. There's something going on there, and that this one needs to be focused and needs to be processed earlier, something like this.
And maybe you can say something if you have several robots and you want to couple them, swarm activities, something like this. On what layer of your layered system will you do which coupling? So which effects will make which layers talk to each other?
So typically in this approach you will make the operators of different robots then talk to each other, just that you don't get in trouble with the hard real time for the controller parts.
Is there any situation where you would couple also the controller layers and have a real-time communication?
Not sure. We didn't. So we are not working on this currently. Not sure if we will have some example for this.
For example, if they are cooperating, handling together something, need to be synchronously operated.
Yeah, maybe.
Okay. Yeah. Other questions? Okay, then thank you for the presentation, and we will hand over to the next part of the session.
Very sincere thanks to our session chairs.
Yeah, and I have to distribute the certificates one moment.
Okay. Thank you.
Yeah, thank you.
Thank you very much.
Thank you.
Professor Roll, thank you very much. You are a true friend of this conference.
So it's your task.
German. Okay. I'm ready.
Okay, we are starting second half. There's another 2 presentations. The first speaker is Gregor Busevich.
Yes. Here.
So we hope to see more details soon about the manned aerial vehicle subject to cyclic production flow constraints.
Yes, yes, yes. Okay. Ladies and gentlemen, my paper I would like to show you a presentation about the cyclic scheduling and routing of unmanned aerial vehicles, in short drones. The presentation has following form, and let's start from the first point, the cyclic system. Here is an example of cyclic transportation system where we have
8 vehicles here, which are moving along the given cyclic roads. These vehicles are used to transport materials and workpieces between the workstations along, in this case, 2 production roads, red and blue. Please note that the operation of these vehicles are cyclically and production operations are cyclically too. Therefore, this system can be easily represented by the following concurrent cyclic processes system, in short CCP system, where the workstations are represented by the resources, vehicles are represented by the following local cyclic processes with these big tokens here. This blue process represents these blue vehicles, and the manufacturing streams, red and blue, are presented by the following multimodal processes, red and blue. In this system, we assume that the local processes representing vehicles are executed concurrently and cyclically. Moreover, we use the mutual exclusion protocol. That means in one time, one resource can be occupied by only one local processes, one big token. In turn, multimodal processes representing manufacturing flows can be treated as a composition of parts of local processes. For example, this red process can be seen as a composition of part of process blue here, part of process yellow here, and part of process brown here. In other words, this red process with small red token is like a passenger which uses many transportation means, many big tokens to move in this system. Okay, this representation is used to describe behaviors of many real systems, and in our case this is the multi-product batch production system, where the transport operations between the workstations are executed using by the aerial vehicles, by the drones. In that context, the local processes represent the transport operation of the drones between this workstation, these yellow arrows, and multimodal processes represent the production of operations of given production roads, for example, red and blue and red in this case. Okay, so what we want to know? If we know the structure of this kind of system, we know the CCP representation, we know the parameters of the fleets, number of drones, capacity of batteries, and etc., speeds. We want to know what roads of these drones guarantee that in this system will be available the production with this and this stream with given takt time on the output. And to answer this question, we formulate in our paper declarative model, and the first element of this model is the structure. The CCP structure, for example, for this small structure, is described by the following parameters, and among them I should distinguish set of resources. Here, in CCP system we have two kinds of resources, local and shared. Shared resources are here and are the places where processes have to fight to the access, and in order to avoid the collisions between these processes, we use the set of dispatching rules, when one dispatching rule is the sequence which determines the order in which processes can get access to the one shared resource. For example, this sequence, these dispatching rules means that first access to this resource is for process 2, next for process 3, next for process 2, and once again this order is repeated. Okay, this kind of dispatching rules and these parameters determines the possible admissible behavior of given CCP system, and the behavior is the second element of proposed model. And here's an example of behavior for given structure. This is example of cyclic behavior. This is the cyclic schedule. Why cyclic? Because each column, each state, each allocation of processes is repeated with constant period, in this case 24. But how to calculate this kind of cyclic behaviors for given structure, behaviors without collisions, deadlocks, and etc. And during our research, we tried to find the conditions which guarantee this kind of cyclic behavior in given structure. And here is example, short example for of our results, this is part of the set of constraints which should be satisfied to calculate the schedule. In general, these constraints have the following form, and this is the relation of moments of operation beginning of local and multi-modal processes operation, and this relation should be satisfied for each operation in this schedule, each pair of operation in this schedule. Okay, we describe these constraints detailed in our paper, but how to use these constraints to answer our question. In our paper we show that considered problem here and with our question can be formulated as a constraint satisfaction problem, which is a triple X, D, C, where X, this is the set of decision variables, and in our case decision variables contains the sequence of dispatching rules, moments of operation beginning, takt time, and roads of aerial vehicles. And C is the set of constraints which describe our system. Constraints which contains the structure of our constraints describing the structure of our system, and constraints which guaranteeing that this system will be available to cyclic behaviors. In that context, to answer this question, we have to solve this problem. Solve this problem, that means we have to find the value of variable X, which for each all constraints will be satisfied. To solve this problem, we use typical constraint programming environment. In our case, we use Oz Mozart system. This is open source environment for constraint programming. And now I want to show you how to use this approach on the example, small example. Given is the following system with 5 workstations, 1 input and output buffer. We have 2 production roads, blue here and red here. We have fleet of 3 drones where we know the capacity of level of battery, and we know structure of transportation network. Here, this is our flight corridors. We know the times of travels, we know the consumption energy on each travel, and we want to know what roads of these vehicles, these drones, guarantee that in this system will be available the production with given takt time less than 60 in this case. To answer this question, we formulate our problem as a constraint satisfaction problem. We implemented it in the Oz Mozart system and we tried to solve it, and after 76 seconds in this case, we obtained the first admissible solution. And this is our result. This is the road, very complex road for 3 aerial vehicles. This is 1 cyclic roads for 3 common roads for 3 vehicles. These vehicles moving along this road, but in different places. And this road guaranteed that in this system will be available the production with given takt time 53 units times. Here you can see how works our system in this solution. These big tokens, green, yellow, and violet, represent our drones. These small tokens represent transported elements, red and blue, and this is our schedule, and as you may see the takt time is equal to 53 units times. That means in 53 units times this system leaves 1 product of blue and 1 product of red. Maybe you can see for the moment, oh, this red element is transported to output. In our experiments, we tried to find the number of drones which guarantee the lowest level of takt time, and this table shows that for fleet with the 4 drones we have the best solution. And here you can see our optimal solution where we use 4 aerial vehicles and we have the takt times equal to 53 units time. But this solution is possible only if we use the corridors, flight corridors on different levels, and these green corridors are placed higher than others. We have to use that because to avoid the collisions between the drones on the crossing corridors. these two corridors should be placed higher than others. Okay, this is our optimal solution, but how looks the consumption energy? In our optimal solution, if we assume the following level of capacity batteries, these drones should change battery once per one cycle, 1 per 38 units time, and these drones should change battery on the ones from 3 workstations, R1 here, R3 here, and R5 here. Is it possibly the easier solution where the drones change the battery on the one workstation here, and here, and here, and here, but it is possible when we use the higher level of capacity battery, 100 or 200 or 200. Okay, this is our short experiments, and now I want to show you short conclusion remarks. As you may see, the cyclic exclusion problems can be easily implemented in constrained programming environment. Our approach is quite effective because we allow to obtain the solution in about 1 minute for the problems with 5 drones and about 15 workstations. And but in our solution we have sometimes we have to use the corridors with different levels. Therefore, in the future, we want to extend our model by constraints which allow to avoid the constraints between the crossing corridors. That is our future. And now, this is all from me. Thank you very much.
A question: we are using constraint programming and solution for cyclic problems for our distributed real-time systems.
Yes.
For automotive, so distributing the tasks there, making sure that that you can run things in the appropriate time. Did you use any of the let's say partitioning, mapping systems that they use for automotive things, because there's a high number of tasks, more than 1,000, 2,000 tasks that are distributed and scheduled, and they use constraint programming for this, also with similar runtimes. So is there any connection between these two worlds, that you are using this for vehicles, for scheduling?
We use only constraint programming environment. In the future we want to try to different ways to solve these problems, because computational complexity is very high in this case, and yes, we plan to, in the future, try the other solutions. But now we start from this because it is very flexible and comfortable for the model. And if we know that it works in this case, in the future we want to extend, try to use the other models with not okay. We try to find the other. We try to use and other models and other environments to solve this kind of problems.
More questions? No. Thank you very much.
Thank you very much.
Grzegorz, there is a certificate for presenting your talk.
Oh,
Next speaker is Murat. Here Hendrik from Sumy State University presents total integral fuzzy power quality assessment for decision support system and management of power network based distributed generation.
Hello everyone. This work is completed with my colleagues from Kharkov National Technical University of Agriculture and doing in two universities in Ukraine. The next university is the Sumy State University, my university. Let's consider the typical small distributed power system consists of the array of solar panels of the building and equipment with wind turbines and energy storage bank, and also there is connection with the external power grid. Described the significant advantages for such hybrid system, it is very difficult to assess the capacity of renewable energy sources used in economy. As it clearly illustrated for this figure, there are two flows, electrical and information, according to main idea about systems stable reliability. Firstly, it's important to build adequate distribution between sources based on electrical flow. Information flow support is provided by the management of a power system using smart grid technologies. In smart grid, it is necessary to control both information and electrical flows, and here important to notice that control of information flow helps to control electrical flow. To control them, it is necessary to use different energy management stages. The power network with distributed generation is characterized by a rapid change of operation models depending on external conditions. The process of making decisions is, in case of distributed network management, is characterized by big amount of discrete variables that have impact in overall system. Operatively of decision-making process plays an important role in the management process. It can be achieved by means of decision support systems. So it is necessary to implement information technologies in the management process of distributed power network operation models. This solution will allow consumers to make decisions with provide generation efficiency and consumption of electricity. Generally, the input data are the forecast values of the load demand, the needs in renewable energy resources for central period in future, and the market price for electricity. The main function of such system are to manage the power and the energy between sources and load into the smart power network with distributed generation, to make a schedule of energy generation and to evaluate the cost of energy production and emission. The planning, simulation, operation and control of electrical energy system involved information and phenomena that are naturally associated with temporal and scenario dimensions. Each one of these dimensions has specific scales and granularity requirements associated with related system behavior. The planning, safe and optimal operation management of smart grid is a multidimensional and multi-scale problem. Multi-scale dimension making is a growing area in multi-scale optimization, the aim of which is to develop a generalized strategical formalism that describes a large variety of complex systems in an effective way. As a result, the entire system is optimized while considered the interaction between the scale by means of coordinated information. We observe the smart grids customers are faced with a multi-scale dimension making problem, energy management based on a set of criteria. The characteristics that occur during this process is listed on this figure. The process of creating power network with distributed generation is considered as a set of tasks at each involved stage: planning, design, installation and operation. This study focused on the operation stages. We are proposing the unified integrated approaches to addressing the problem of improving the quality of decision-making process with management of operation power network with distributed generation. And we focus on the successful functioning of the distributed generation infrastructure. The electrical power quality can be considered as the main performance criteria of the distributed network, but in fact the term electrical power quality is fuzzy. The purpose of the study is to determine the performance criterion of the distributed network, which is power quality index in the fuzzy form, for use it under condition of uncertainty information in decision support system. In order of achieve this purpose, in view it is necessary to solve the following tasks: representation power quality in the fuzzy form and formation integral fuzzy concept of fuzzy power quality. The assessment of power quality index The assessment of power quality index are disclosure of information uncertainly during the analysis of the power quality index are considered today as uncorrelated task. The deterministic approach is widely used for calculation. As to the measurements, according to the international requirements of methodology and standardization, sorry, I need do something. As to the measurements, according to the international requirements of methodology and standardization, it is recommended to consider the main quality assessment of measurements as unsaturation. Some Instruments for measurements of the power quality index can present the result in the form of a histogram. After normalization, such histogram can be regarded as a fuzzy representation of the power quality index in the form of fuzzy set with a step membership function enveloping the histogram. The power quality index as voltage fluctuation, non-sinusoidal voltage, voltage imbalanced, frequency deviation, etc. are measurement within 24 hours. The instrument forms a histogram using the given set of measurements. The range from PQ power quality index minimum to power quality index maximum is divided into n of equal interval di, and the histogram for frequency of getting of the power quality index measurements into special intervals is built. After normalization, we obtain the histogram. We form fuzzy set of the power quality index based on the obtained histogram. This set is within the range from power quality index minimum to power quality index maximum. The membership function is a step function mu, enveloping the histogram. As we can see, this representation of the quality index does not require consider the fuzzy set into any particular case of a well-studied type of fuzzy set. Consequently, there is no need to make a significant upgrade of the measurements instrument software. However, the peculiarity in the measurement of a quality index with the particular power networks is still presented. Power quality limits are different in the form of interval of normally admissible and maximum permission values. That is, the limit definition itself contains an element of uncertainty. It is because there is a necessity to define if the power quality index meets the quality limits with the interval between the normal admissible and maximum permissible values. For the decision-making system, it is important not only to make the recommend when the quality index exists the limit, but also it is necessary to prevent the risk of such situation. These limits can be represented by a fuzzy set that is fuzzy interval with trapezoidal membership function. The values of the power quality limits minimum and power quality limits maximum is in this equation are specified in the normative documents. The conformally degree of fuzzy values of the power quality index to fuzzy power quality limit can be evaluated by the membership function of the intersection. In this case, the conformity degree is preferred to express as number rather than function. So we propose the following approach. The interaction of fuzzy set can be numerically estimated by the area of interaction of two shapes, S shapes. The first one is shape both the sorry. The first one is a shape bounded by the abscissa axis as a membership function of the power quality index. The second one is the shape bounded by the abscissa axis as the membership function of power quality limit. The membership function of conforming of the fuzzy power quality index to the fuzzy limits of power quality can be representation as this. Let's consider two cases which show the difference between fuzzy and deterministic approaches. In the first case, the measurements of the voltage in the phase A is the following: 25% of the values existed the upper limits. According of the limits, the power quality index for voltage deviation in phase A does not conform the limits. Fuzzy assessment of the conformity of these parameters to the limits was 0.699. This assessment versus the deterministic one presents the degree of conformity of these parameters to the limits. In the second case, the voltage measurements in the phase A show that this is no violation of the limits. So the power quality indexes for voltage deviation in the phase A conform the limits. The fuzzy assessment of the parameters was 0.801. It means that the value of this parameter approaches in the limits. This data can be used in the decision support system for preventive actions regarding normalization of voltage deviation in the phase A. Also, the fuzzy assessment provides the possibility to monitor the quality assessment, the efficiency of the accepted decisions, aims to improve the electrical power quality even if quality indexing conforms these limits. The considered case shows that the fuzzy assessment of the quality indexes is more informative in terms of intelligent decision support system. There are a number of indexes characterization various aspects of the power quality. Most of them can be presented in the fuzzy form according to the proposed method. The fuzzy representation of the conformity of the quality indexes for the accepted limits allows us to form integral fuzzy concept of the power quality. This is because the fuzzy set optimization operations are definitely projected on membership function operations. In this case, the physical nature of the quality indexes is of no consequence. The simplest approach to the formation of the integral concept of the quality based on the logical operation of fuzzy set interaction was given in many works research. The fuzzy concept of quality is formed as this form. In the case different types of load are critical for different power quality indexes. Therefore, it is possible to form integrated generalized quality indexes for power networks with predominance of some type of load using the described approach. For electrical load, for lightning load, for devices with microprocessor control. And the main conclusions of this talk we can see of this slide. We presented for you the falsification method of assessment of quality indexes and quality limits of power electrical. I'm ready to your questions, to ask you questions. My contact on this slide, please.
Please. Okay, I have a question. How you obtain these values for the voltages from the sensors? They are shown on hourly basis? In the very first slides somewhere it was a diagram of the spread of different voltages.
What slide?
That one.
That one?
Yes. With what precision they obtain it? How frequently? So this is the timeline, right?
Yes.
And
This
it's
is
obviously
voltage. This is.
yes. Obviously,
Frequency of
during the
voltage
night time it is
420.
increasing, right?
Yeah.
During day it is decreasing. During night exactly increasing. And so, how frequently you are measuring it?
Okay. In time?
Yes, yes, yes. What time intervals?
I don't know. This is not my
Because
work.
here is shown precision with some minutes, right?
Yeah, I think.
But is it like every
Every minute.
every minute?
Okay, like every minute. I think it's.
More questions?
Thank you.
Okay, thank you very much.
Also, thank you to our chairs, Professor Allegro. Thank you very much.
Good.
And Professor Ira, thank you very
you.
much.
So what is now? Lunch break?
Yeah, we will have lunch now.
Hello, everybody. Let me introduce myself. I am Professor August Lopata, and I'm a chair of a special session on intelligent methods for data analysis and computer-aided software engineering. And we will have 6 presenters in our session, and I suggest that the speaker will have 10 minutes for presentation and 5 minutes for discussion. So totally 15 minutes for each speaker. And let's start. The first speaker is Olesa Kuznikova.
Hello everyone. So I'm Olesa Kuznikova from VGTU, Vilnius Gediminas Technical University. And today I'll talk about adaptive cloud resource provisioning and auto-scaling for cloud-native applications. So before talking about adaptive resource provisioning for cloud applications, so it's worth mentioning that cloud is already exists like for more than 20 years. However, sometimes in literature, people are still confusing virtualization and cloud. And the main difference is that cloud is not just a virtualization. Yeah, it uses virtualization. However, it's a service which you use it as a self-service. You can request different resources, and for which you are paying as you go. So you are interested in efficiency for those resources, and also cloud provides you a rapid elasticity. So virtually providing unlimited amount of resources you need, so you don't care too much about the underlying infrastructure. And in the same way, like it took around a decade for people to realize that development of cloud applications for cloud is not the same as developing the application for on-premises solutions. Where you have just a virtual machine that is stable, you spin up your application and it runs. In cloud, mainly the cloud infrastructure or platform is not stable platform. It's designed to be elastic and automated. So like very often the resources needs to be switched on, switched off, and as such your application should be ready for such changes. So in general, cloud native application is different from classical application in the way that it's like a distributed system. Yeah, it follows the good practices that it should have like a isolated state. So the components don't need to have some state in it, or like it should be like minimized at some specific place. Its components should be loosely coupled, but the main the most significant characteristics are the elasticity. So when you're developing applications, so it should be developed in the mind that it will be elastic. So it will allow you to utilize as much as resources as you need and try to achieve usage of resources in such way that you don't use too much resources or less resources than you need. So in general, auto-scaling and resource provisioning are the basis for elasticity of cloud applications. And the issues with auto-scaling engines that are provided out of the box in cloud or by resource schedulers, something that in most cases they are based on reactive rules based. So it's like you specify a specific amount of, for example, resources of CPU, and when the threshold is reached, then the auto-scaling engine triggers the action and provides you additional resources. However, this can lead to many different issues like resource over provisioning. So you once again don't use your resources as efficient as possible, but sometimes resources might be provisioned too late. Yeah, and this might lead to SLA violations because service will degrade. And another thing is like as cloud native applications are now commonly developed using microservices architecture, which has a lot of small pieces and components, you need to coordinate that auto-scaling auto-scaling activities. Because, for example, we have a front-end web tier, which we start scaling, and it scales so much that, like at backend, you have a database which not able to cope with the load that was allowed to be reached to that database. So like instead of getting the service improvement through the auto-scaling, you're getting the service degradation because you killed your database with too much load that you open from your front end. And another thing, like commonly auto-scaling solutions that proposed in literature, they're all almost, in most cases, oriented in infrastructure. So either virtual machines or containers. However, cloud application can run or utilize other components which are provided by cloud as platform as a service. So what it means, you can get the database as a service, but you don't know, you are not aware, are there any, how many VMs are there, how many CPUs there, so you're just requesting a capacity, and you're using the provided capacity, like in form, for example, database, and you can scale it vertically, not only horizontally, for example, so you're just getting more power for your database. So once again, when you're making a decision on auto-scaling, you need to coordinate the action as database might scale slower than your front end. And another thing with algorithms is like analyzed in literature that there is no one single auto-scaling algorithm that fits all the cases. So one of the algorithms are better like for unpredicted logs. Some algorithm performs well when there is like a load in the form of spikes or unpredicted, and other algorithms are better working with when the load is quite constant or like not fastly changing, or you have a periodic load with specific pattern. So several works are suggesting to have just solutions for that. So like either you can select algorithm based on specific significant metric. Yeah, for example, if you have a database, you cannot scale your web server amount of web servers in the same way as you would be scaling your database, because its database will be slower, it will take more time, and front end you can just like use a container, pop up it in milliseconds, and that's all. And also the same is like there are works that recognize the pattern, and based on the type of pattern of load or connections, the specific algorithm is selected. So, and of course you can also specify the type of your application, you know the type of application, and based on that you can manually select the algorithm you need. So to summarize it, like the adaptive auto-scaling and resource provisioning system should be context aware. So it needs to know about the specifics of your application, like what resources it needs, like what kind of this application, is it stateful or stateless, so how to scale it. It also should track the dependencies between the multiple components, so it should be topology aware, and also should be able to scale resources independently. Is it like virtual machine or container, or it's like a platform as a service, so you are getting more storage as a platform, or you're getting a database, and so on, the same containers. So like what is the proposal like to achieve it? So like adaptive auto-scaling system should have more than like auto-scaling engine itself, which cannot cope with all those complexity, and monitoring system. But as addition, it should have a system state store, which tracks the state of your existing setup of your application or system. You know, for example, that like your, once again, like previously I mentioned, you have a front-end tier, which is like now at capacity level, for example, 1, and you cannot, maybe better vice versa, you have a small database, so at this stage you cannot yet start expanding your front end before your database haven't like expanded. So like this is the purpose of system state store. The execution engine is like an engine that coordinates the different auto-scaling and resource provisioning activities. So for example, you need, your application can consist of multiple components. Yeah, it might, as it's running on cloud, it can be like just like a traditional application. It might be part of the Docker. Yeah, it can be implemented as part of microservices. It might be used as a function, or use a platform as a service component, as mentioned before. So execution engine would be responsible for coordinating the request of different resources from different tiers, either from platform as a service, either from infrastructure as a service, like, or talking to container schedulers if you have a container scheduler and asking for additional resources. And system definition store is generally like used to define your system, the topology, the requirements. So you can, for example, use Tosca templates, which define the dependencies between your application, between the platform, between infrastructure. And as can be seen, there is like a lot of products shown that can be realized with, could be used as part of this. So you don't need to create all those components that I mentioned here. A lot of those are prepared already. However, like execution engine, so there is like still in unmature stage. So like only a few products that can work together with independently. Is it infrastructure or is it a platform as a service? So it makes seamless for your application or like for you as a user of the system. It creates a layer of abstraction from cloud platform and infrastructure. And as optional components here, it's mentioned once again, you can go with container scheduler, which will do a lot of things that are mentioned here in core components section, and cloud resource provision like Terraform. It also can simplify your work because you have your execution engine, and instead of it to talk to different clouds like AWS, like to Amazon Web Services or to Azure or other cloud, you talk just to that mediation layer created by Terraform, and it requests for you like it talks to cloud resource provision API and asks for resource. So you just develop your system only to talk to that Terraform component or cloud resource provisional component. So in general, like after the studying a lot of documentation and products, so there is like a gaps, and which the proposed components or architecture was aimed to address is like that there is need for coordination between different components of your application, and it's also like between the resource provisioning, like if it's like ES and PaaS, platform as a service or infrastructure as a service, and you need to track the dependencies between various layers of your application. So auto-scaling solution needs to look at it. And and that simple auto-scaling algorithms are not enough to achieve elasticity for modern cloud application, as there is no algorithm that fits all scenarios. And in general, most of the components of proposed architecture can be reused from existing products. However, auto-scaling engine itself and execution engine needs to be like worked out, and it's like a further area of research for future development. So.
Okay, thank you. So, Questions?
So I would like to ask one. I read the article and in the end I found that you mentioned that your proposed architecture suggests usage of optional mediation layers, yes? And
yeah, it's like...
And that there is some disadvantage, that there are more additional points for failure, yes?
Yes.
So my question would be, are you planning to do something to solve that, or just somehow adapt your solution?
No, it's more like, it's like you're choosing between two beds or like smaller bed. Yeah, you either can, it will still depend on your application. If you want to have like a cloud independence, yeah, so why this component is like optional, because if you don't try to achieve a cloud independence, you can develop that execution engine specifically for specific cloud, and you don't need that mediation layer, but you are losing portability. And but if your goal is like to have a portability, then you have like to choose like give something and take something. So this is.
And I have one question. How do you expect, what will be the final result of your research? Will it be architecture, framework, solution, methodology, methodic, or how you could describe it?
So the goal of this was like just to be like as a starting point from where to start.
Yeah.
So because it overlaps together with a lot of with microservices architecture, which is popular now, and at the end of the research, it would be like maybe some kind of architecture with the best practices and like
recommendations or something.
Yes.
Okay. More questions? Okay. Thank you. And this is the certificate, this petition, and this is one more for you.
So okay. Thank you.
So next presenter is Aurimas Kolovskis.
Hello everyone, my name is Aurimas, and I today will talk or like continue the discussion which my colleague Alessa started about cloud software, and I will focus more on metrics collection and aggregation for auto-scaling. So, but first of all, let me start with the latest trend and our motivation here. First of all, last few years, all new applications are basically cloud-based. Everyone is moving to cloud. Even old on-premise solutions are migrated to cloud. So we see, especially in the last few years, the huge movement to cloud. This means that software as a service solutions must handle high loads because one software needs to serve multiple tenants, which a lot of users. So it will be definitely high loads with certain applications. Moving forward, scaling, automatic scaling is based on system load is definitely advantage here, because you need to do some cost saving, and you cannot have multiple instances running at night when there is no load at all. With that, software development practices, new software development practices emerges, such as continuous delivery. We want to release software more frequently, once a week, once a day, dozens times a day, and this leads that all modern cloud software is based on microservice architecture, which means that we could scale specific service instead of the whole monolithic application, and also release it service one by one at any given time. So what are the potential issues? What could be the problems with that? So Basically, currently the scalability resiliency are based on infrastructure level metrics, so CPU, RAM, and there are no options to track application specific metrics. For example, business transactions made, and it's hard to ensure does the application meet SLA. The predictive scaling, the popular cloud providers does not provide predictive scaling based on machine learning methods. So this is also a very useful area. We could implement solutions. Furthermore, a big issue is that vendor lock-in. If you start using any cloud provider and start using it, tools, services, script languages, you actually locked in with a specific provider, which could be a problem in the future when you want to migrate to another one. And if you want to run your software in different cloud providers, I mean, some different services use best cloud for that job, means that you need to manage all application, and it's very complicated to do it centrally. So our goal, kind of ultimate goal of all researchers, is to create a self-adaptive microservice architecture which is able to monitor, scale out, scale in itself independently on any infrastructure provider. So in this particular research, the focus is to metrics, and we need to collect and aggregate infrastructure and software related metrics. We need to aggregate application nodes topologies, so we need to know at any given time what the status of our application is, how many nodes up and running, and so on. We need to address data storage issues and ensure quick queries. I mean, metrics from a lot of microservices generates a lot of data. We need to store somewhere and ensure quick fetch of data for our auto-scaling module. We need to have ability to manage these data amounts. We need to filter it, transform it, and so on. So this task, I addressed it in my work there, and proposed an architecture which, we'll go more details with that, that on the left we have any kind of software application, which could be many microservices. It could be few, or could be tens of microservices, and it's kind of fits to any size of application. Application is actually independent on scaling logic, because you can plug in any application to that. There's an agents which are shipping metrics data from any level. It could be infrastructure, it could be container levels like Docker, it could be your custom application metrics, like number of business transactions, response times, or so forth. And we need to aggregate it to one place, and then apply auto-scaling logic there. So the data, for data storage, we choose quite a popular technology stack is known ELK, Elasticsearch, Logstash, and Kibana, which primarily known for log segregation. But actually we saw that you could use it also for metric segregation there and storage. Then auto-scaling engine could fetch those data, run some algorithms, and instruct infrastructure provider or platform as a service provider or whatever provider with the scaling instructions, so to scale out, to scale in the application. Also, we could common way to have a microservices, there's a kind of service discovery, and service discovery stores the service topology and ship it also to Elasticsearch. So I made experiments from two angles. Is that measure the performance of shipping data to data storage, what our delays are, and querying the data from that. So that's what I needed to validate it if it's a good tool set for us. So regarding metrics, shipping and processing, I ran into on very simple server based on Amazon. I had 4 million test documents in there, and I was shipping, tried with different numbers of agents, and the results were that there's kind of no big noticeable impact of data processing time. So we're actually able to ship a lot of data in parallel and store it. So fast write operations. And we see that we have kind of around 3 seconds delay there, but in our task, in our problem, it's kind of tolerable delay. We could live with that. Regarding query execution duration, we were running on the same test environment with the same amount of data. We saw that actually it's kind of linear dependency between the amount of selected data and the time. So as much data you querying, it will get a bit more time. But also the network were the bottleneck, because to transfer the huge amount of data, it takes more time than actually query it from the data store. So conclusions about that. So I made a validation that ELK stack is actually able to cope with large amount of data and execute queries fast enough. Data shipping was tested with 20 agents and hadn't noticed any degrading performance. I also proposed a solution to collect and store application nodes topology. So the future work where we'll be focused next is on the auto-scaling engine, now to work with the data, apply some kind of algorithms there, yeah, that's kind of my research. Thank you very much.
Thank you. Questions time? Any questions? Okay, I have one.
Yep.
Could you please show the slide number 5? Yeah, okay. And it is interesting how many software-related metrics do you plan to collect, yeah? And how many groups of these metrics exist, and how you will store them, and
it could be as much as we need to run auto-scaling.
Okay, but what level of numbers? It's thousands, millions?
No, I guess it's on up to 10 or up to 20. Is that?
Okay.
I mean, some basic metrics which you could ensure.
For example.
Response times, business transactions, number of business transactions you're executing, because that old solution does not only can do auto-scaling, but it could be used to identify anomalies like memory leaks, like you have a huge load of server, you could see from infrastructure metrics, but you see that your business transaction remains the same, so it means there's somewhere a leak there.
Okay.
So, and it could be used for regular monitoring, basically.
Okay, that's clear for me. Okay, thank you.
Please.
Okay, of course, the subject here is very critical, especially if you have a cloud infrastructure. The first thing that you must consider always is how you are going to monitor all your microservices running there and evaluate the infrastructure that you have there. Did you test any of the open platforms that are available, like Prometheus and others?
Sorry, which one?
Prometheus.
Now
there is a number of platforms that they are already, you can use it in order to collect information regarding your microservices and the virtual machines that you have, etc., and build your own monitoring system and making the analysis after that. Some of them are open, some other are you have to pay them, but there are some approaches.
Yeah, but they usually, my colleague Alessa did a thorough review of those, and it seems that some tools, there are a lot of tools you could collect metrics and do it for monitoring. But our goal is not the monitoring, our goal is to fetch data as much as we need, store it, and based on those data, do auto-scaling. So I haven't yet saw the tool like that in the market for microservices. So.
Okay, more questions? No? Thank you. And now we have defined procedure. Sorry.
Oh yeah.
So this is the certificate for previous presentation in the article, because you are the co-author of this article. Yeah, this is for this presentation certificate. Yeah, and this is a certificate for your colleague as co-author. Yeah. Okay. So next presenter, we will have two presenters, is Vladimir Kamanevsky and Ralph Christian Hotting.
Yeah. Hello, everybody.
Sorry, microphone is here.
Oh. So. Yeah. Hello, everybody. My name is Ralph Hotting, and that's Vladimir, and it's a pleasure to present our joint research project of Aarhus University and Potsdam University. Potsdam University is doing research since a long time on the quality of Wikipedia articles, and we are doing research on search engine marketing metrics, and in our project we try to combine both, and therefore we figured out a research question: how can we use SEO indicators, also indicators of search engine optimization tools for the measurement of the quality of Wikipedia articles. So what is the assessment of these indicators for the quality, to measure the quality of Wikipedia articles? That was our research question, and yeah, we would like to start with a brief introduction to Systrix, to Wikipedia, and we proceed with our experiment, the data sets, and finally we have a conclusion and some words about future work. Yeah. 50% of the world population is almost using internet services, and everybody knows that the most important service is Google search, and regarding or connected with Google search, we have a lot of new tools which assist digital marketing and digital activities on the internet. And and furthermore, we have a lot of course, a lot of visible domains in the search engine results, so-called SERPs. And one of the most important domains, of course, everybody knows that the domain is Wikipedia.org, and that's why Wikipedia.org is so important. We try to figure out how can we measure the assessment of specific indicators. Here, just some words to Wikipedia. It's the 5th most visited website in the internet. We have 48 million articles now, and we have now more than 300 language versions. Yeah, it's open, and it's used for enriching knowledge bases. Some articles still have a poor quality in Wikipedia, and we have a quality grade in Wikipedia, but most of the articles don't give a specific grade, and that's why we think that indicators, different indicators, are very important and allow to build models for automatic quality assessments of the articles. And several important indicators are related to references in Wikipedia articles, and we focused in our research especially on references in Wikipedia articles. Yeah, some brief overlook to Systric tool. We have a lot of tools in the area of digital marketing. In Germany, the most important tool is Systrix. Systrix has the highest market share. Now more than 50% of companies which are involved in digital marketing are using Systrix. And this tool is a very powerful tool. I had a lot of research activities. I did a lot of research with the metrics of Systrix. They allow to support the whole digital marketing process based on specific metrics. And we used this tool to analyze Wikipedia articles in various granularity. Mainly we focused on the host, but we also had a brief look to URLs in Wikipedia articles. Yeah, we selected 5 indicators. There are much more indicators available in that tool, but we concentrated our research on 5 indicators. We used social signals, and this indicator, of course, covers a large scale of social networks like Facebook, Twitter, Google+, LinkedIn is also implemented in the Systric toolbox, and Pinterest. Then we used the metric SEO. It's called SEO in the tool. This metric shows the number of keywords in different keywords, the different keywords of a domain, which are achieved in the top 100 SERPs. SERPs means search engine result pages. Then we used the metric backlinks. That means links from the external direction, external links, which refer to the domain or to the website. Then we used the metric universal search results. These ones are also very important for indexing of a website, and they are also part of Systrix. And the most important indicator is the visibility index. Many agencies use the visibility index for their price for pricing their services. They have quite often contracts with customers. As higher the index is, as higher the service fee. is for the companies. No? And usually the index of a website is generally created by a keyword pool in which each keyword is being ranked and weighted within the Google research results. Yeah? Systrix, for example, is calculating with a pool of 1 million keywords and keyword combinations per week, means weekly. Yeah. These are the main selected indicators, and we use these indicators for our experiments. And now Vladimir will proceed with our experiment.
Thank you, thank you, Ralph. Now, a few words about datasets and results. So we choose some of the language versions of Wikipedia. One of the most developed versions and the most developed version is English Wikipedia, and we also take into the account French, German, Spanish, Italian, and Polish Wikipedia. We use parsers, which allows to extract different information about references, including URL address. So in English, we have over 26 million URLs of references, and next versions have 432 million, over 2 million addresses of the references. We also extract hosts from these addresses, and we had almost 2 million different hosts in the English Wikipedia. So if we choose the most popular hosts in each languages, we talk about 5,000 the most important hosts. We can see that there are some overlaps between these language versions. But most of the references are specific for concrete language version. So when we analyze these most popular hosts with Systrix tool, which give different indicators. For example, this slide presents results of the analyzing this host using visibility index. We see that in the bigger value is in the language version which are related to specific country. For example, if we analyze hosts from German version of Wikipedia, we have visibility index from German side. We have the highest value. Another example, for example, Italian from other language version. From Italy perspective, visibility index is the highest in the local language version. Another indicators which we took into the account and which was described earlier by Ralph is SEO, universal search, and backlinks. This graphs presents distribution of these metrics in specific language version. So we see that in German, the values of SEO metric and universal search is higher than other language has. But in situation with backlinks, English version has values, the highest values. We also try to analyze Wikipedia articles. So we divide in English Wikipedia articles in 4 categories. We want to analyze high quality articles and articles with worst quality class. But additionally, we wanted to choose from these 2 categories popular articles and not popular articles. So we have 4 categories. Featured articles in Wikipedia is articles with the highest quality. Stab is the worst class. And here presented indicators which we are taking into account. Visibility index, social signals from different social networks, especially Facebook. Here we, using ICIST tool, can extract metrics, some special metrics from Facebook. For example, Facebook likes, only Facebook shares, or how many people comment this article. Also, we took into account other social networks as Twitter, LinkedIn, Google+, and Pinterest. So this slide presents shortly results which we received. If we analyze visibility index, that we can see that here, when we have popular and articles with higher quality, we have significantly higher values of this metric. It's also interesting that articles with high quality but which are not popular have zeros on every country from different countries' perspective, because visibility index can be measured from users from different countries, and this value can be vary. And if we take into account popular but articles with the worst quality, we can see that it's closer to 0, but there is some values. If we analyze social indicators, such as, for example, signals from Facebook, Twitter, LinkedIn, and so on, we see similar situation, that unpopular articles, even if they are high quality, usually have 0 comments, likes, shares, and so on. But if you compare popular articles and compare the best articles and the worst, then we can see very big difference between values. So what are the conclusions? First of all, we can see that CEO indicators can somehow show differences between articles from different groups. We use such metrics as visibility index, CEO, universal search, backlinks, and social signals from various social networks. We also see that values of these metrics are significantly higher in articles with the highest quality grade. Popularity also shows that these articles have higher values of these indicators, and also we have some connection between country and articles from this from local language version. There are a lot of directions in which we can continue this research, and this slide presents some of them. For example, we want to compare these indicators which we received from Systrix tool with metrics from other similar tools in the market. We want to add some additional indicators from this, including this tool, different tool, expand number of articles, and of course expand number of language version. As Ralph said before, Wikipedia has over 300 language versions. We also want to take into account possibilities of the different granularity of the URL addresses of the web pages. We want also to learn how to detect language-sensitive topics in Wikipedia, because some of the topics can be described better, for example, in English. Some of the topic, for example, in Lithuanian language can be described better, for example, Lithuanian cities. And of course, this and future researches can help to improve different projects related to quality analysis of the Wikipedia. For example, we have project wikirank.net, which is used for quality and popularity comparison of the Wikipedia articles in different languages. Infoboxes is more related to analyzing quality of the info boxes in different languages. And there is also project Wikibest, which is in some game form, propose users to analyze quality of the data in multilingual Wikipedia. So that is all. Thank you.
Questions?
Just a short one. You have done a huge work and have a lot of results. And which was the most surprising result for you in your research?
For me, I think that there's big difference between these indicators, because we has popular article. Article can be popular, but it's not mean that it has highest quality. So this significant difference between values, for me, it's maybe some
thousands times.
Yeah, sometimes in 1,000 times.
Okay, I have one question. Could you please show the slide number 8?
Yes.
Okay, I wonder, are these indicators? It means that there are the criteria, yeah, criteria, and are listed here the indicators groups, or there are indicators. Are you using only 5 indicators, or each this group can have huge amount of sub-indicators?
It's just one indicator.
Yeah.
Social signals.
Yeah.
In the tool itself, you can split this indicator, and you can also figure out a metric for Facebook and Twitter.
Okay, and for example, how many metrics do you use in Facebook, for Facebook?
Just it means just the links from Facebook.
Ah, okay.
No?
Okay. Yeah. More questions?
Also the quantity of social signals.
Okay.
Another simple KPI could be the amount of the information or the amount of pictures that you can find inside an article of Wikipedia.
It's
in
true.
most of the cases, when you open just a page of the Wikipedia, if you see very less amount of information, you can understand the quality also of.
It's true. A Wikirank project use these indicators, images, references, sections, and something else. But because it's not only article which are involved in, and for now, it is possible to extract over 115 different metrics extracted from articles and some services connecting with Wikipedia. of course, this the goal of this research is to try to include in this group of different metrics also metrics related to CEO. Maybe in the models, in this complete models, these metrics will have high importance.
100% correct. It's just a sub-project.
Okay, thank you.
Thank you very much.
Okay. So the next presenter is Andrea.
Hello, my name is Andrea Germanaite. I am from Kaunas University of Technology, and I would like to introduce our research in the field of basic urban pattern description. First of all, the goal of our research was, and still is, to investigate and create the methodology of a description and application of spatial patterns used in geographic information systems. The first two tasks of this research was to describe a very basic urban pattern that could be used in spatial analysis of vector maps and overview of some of the spatial analysis methods. So I would like to give a short introduction in other works, and at first I should mention some of the basic concepts. We all know what is pattern, but for example, like pattern if in software engineering or pattern in computer architecture. But in this work, we would like to talk about such logical patterns, like for example, core periphery or center periphery. We all know that city has a center and some surrounding areas. And if we look deeper into this pattern, we will see that it could be seen like two meta patterns. It's a center and a border meta pattern. Later we should look what is urban pattern. There are very well known author Christopher Alexander that described more than 200 of urban patterns, such as countryside finger pattern. Here you can see in the first picture how countryside and city meet each other, and so the inhabitants can easily reach city facilities or go back from the city to the countryside if they live in countryside, like for example such pattern. And below are two other patterns like city layout patterns. City layout can be sectoral or radial or linear, and these are also urban patterns. Now, when we know what is a pattern, we should look in what is spatial object. Spatial object could be simple one, it could be a composed object made of some parts. It could be complex object that also is made of few parts, and some parts are even not connected to it. And then with these basic concepts, we should look into urban pattern specification, also look into spatial data models and some methods of spatial analysis. I will not go into details because it's it's too long. And now the problem and what was done. The main problem is that each urban pattern, it doesn't matter if you take Alexander patterns or other system of the patterns, it looks like we have the same format. It contains some example, context of a pattern, problem, solution, connection of other patterns, but usually it's in the form of text. It's just a description or just a picture, like it could be even a photo. And so the problem is that all patterns are very different in complexity, in hierarchical level, that the pattern can appear in a city layout, in some closed area, or even in the building, like huge buildings like hospitals and airports. And all patterns have very different attributes and very different spatial features. So possible solution to describe urban pattern was to take some urban patterns, to make some description system for them, look into their data model, then use them in some pattern analysis, and then go back to that urban pattern and look, maybe there is a need to add some more attributes and similar things. In this slide we can see benefit and value, what those patterns are about. It's if you are using patterns in spatial analysis, it's possible to interpret and forecast many spatial objects features, and such answers like where to build new food restaurants, or where to put entrance to some shopping mall, in which part of the building it's better to do this. Such questions could be answered. So this is the first result, very simple diagram of description of urban pattern. We see that our pattern is made of several meta patterns, and meta pattern it has shape, some physical expression that could be put and draw on the map, and also we have just simple pattern. Also we have composed pattern and complex patterns, and each pattern has configuration. It's the idea of how many meta patterns it's made. Also, it has context, because we should know should we use this pattern or look for this pattern in the city or in the district or in the building, and of course it has operation that should look for that should allow us to calculate that urban pattern, and that's all I think about this. Now, just a simple example how this look in reality. If we take some real patterns and some real data, then we have our pattern in the middle. We have two meta patterns like center and border, as I said before. We could see that those two meta patterns, they made up this core periphery pattern. And also, if we go more to more complicated patterns, we will see that we have composed pattern and some generalizations like concentric city layout, sector city layout, linear city layout, and in the other side complex pattern. But the example of such complex pattern could be multiple nuclei pattern. It's a city that has more than one center, and we just can see that such very simple pattern description could be suitable for simple patterns. Now the next idea was to look into meta pattern, because meta pattern has its own shape data model with very simple spatial primitives data model. It contains geometric and topological information, and that now we can see the completed 3D urban pattern, the same the same items we saw before, pattern and meta pattern, and now we could find how the meta pattern's body, or in other words, its shape also could be constructed from spatial primitives like body, face, arc, node, and so on. So the last question, what was left when we have such a simple description, what we can do with it, and what is our next step. So the next step would be to use some of spatial analysis methods. One of them that looked most suitable for this task was space syntax. Space syntax, it uses vector map and makes a graph out of it, and then it's suitable to model functional and composite patterns, adapt those patterns to different hierarchical levels, and what is the best about it, that space syntax use the same graph for very different patterns. That means if you describe one pattern in one way, you could add some indicators to it, and at the same time, on the same map, you can use other patterns with different indicators and different data and things like this. So conclusions of this research was just to be sure that that basic urban pattern could be used to describe very simple city models. Of course, this city model is this simple pattern description is not good enough for real-world situations, so it should be improved. And this is the task for the future work. And another thing that is planned to do in the future is to use space syntax method possibilities to detect those real-life patterns in real-life data, like in the cities in the whole world, not even Europe, and to improve that pattern description in all attributes and other useful information that could be found there.
Okay, thank you. So, questions? Okay, please.
Okay, I'm not an expert at all in this domain, okay, but I understand that actually you created a simple ontology to describe an urban pattern. Is that it at the end of the day?
Sorry, methodology?
Ontology.
Not exactly, but ontology could be used and, how to say, connected to this thing, but
Okay.
not at this moment.
Okay, and what is actually, in which type of application we could use the results of this research? It's not clear to me, I don't know.
Yes, very good question. You could use it, for example, in S3 ArcGIS, like in any geographic information system. Of course, you need to create a plugin, and that is should be the result of this research. And just you load a vector map in your geographic information system and do some, I don't know,
commands like merge or simplify it, and then you can use some space syntax commands to calculate those patterns.
Okay, very interesting problem domain. Thank you. I have one question, but we are short in time, so I maybe will ask you in private after this section. Okay, thank you. And okay, next presenter is one of the takers, please.
So, hello everyone. As we have not much time, I will try to make it fast as possible. So, I'm Ilona Veitaitė, and my supervisor, Professor Sodrus Lopata, and I'm presenting our paper, Problem Domain Knowledge-Driven Generation of UML Models. So, shortly outline, yes, a little bit of introduction. I will present enterprise meta model, UML models, which we are doing, and the main part, of course, generation part, and example on business elements, business rule elements, variations, and conclusions and questions. So, main problem is that there are a lot of efforts, a lot of methodologies to generate UML models from different things like merging different frameworks, different languages, different patterns, and even natural language. So it is quite a challenge for everyone, and it is quite interesting topic to research. And we are using enterprise meta model. It is presented and used by the researchers from KTU University, Vilnius University, and we are using it like a main object of our, like a ground object of our research. So enterprise meta model is a model which consists of collected knowledge, and this knowledge is already validated and verified, so it can be used in each stage of information system development life cycle phase. And shortly about that I will talk soon. And the main idea that we are trying to combine information which we have in enterprise model and try to generate UML models. So the design phase would be fully fulfilled. And shortly about enterprise model, it's not our result, it's a result of other researchers. We're just using it like a base for our research. So as you can see, it consists from different elements like actors, functions, processes. Processes are different, are material, functions are different, are informational, flow, input, output attributes. Of course, we have business rules, objective, and so on. So this is a concept of knowledge which is saved in storage of any case tool, yes. So we think, we suppose that this information is already correct and verified and validated by the experts, so we can use it. And we are using in UML models generation. So I think you are familiar with UML modeling language, and our research is more dedicated for behavioral models generation part. So shortly about that, I would like to say that, as you know, UML is used in design phase of information system lifecycle. And each of these models can show the same system but in different perspective. For example, we have an element of actor, and actor in use case model has one functions. In activity model, he may have different one. So it's just a different views for the same system. So we are talking about dynamic models, behavioral models, and we are working with this side. So main idea is that we are generating UML models from enterprise model. So we already have all the information, but we have to generate each element. So this is a top level algorithm, transformation algorithm for this purpose. So we are identifying UML model which we want to generate. Then we select and identify the initial element. Then we generate it. After that, we are searching for the element which is connected with that. Then we generate links. And last part is the business rules, which is connected to the particular model which we selected in the beginning for the generation part. So main idea is that, as I said, we have knowledge in enterprise model, and it is already validated and verified, already correct. So it should be quite easy to generate each UML model, but there are some difficulties with that. For example, we have a fragment from enterprise model. Yes, we have business rule, which consists from interpretation rule, realization rule, information processing rule. So we use transformation algorithm to generate these elements, and it is 11 and 12 step of transformation algorithm. And in the result, we have certain UML model element. Yes, but the main idea is that problem is in that this element in different UML model can have different meaning, because, as I said, different UML model has different perspective for the same system. So, for example, in use case model generation process from the business rule from the enterprise model, we can get extend, include, or association, the elements which is business rules in use case model. But as they are generated from enterprise model, we have to have, must have the information which is saved in the enterprise model and can be related with use case model. So we can have the result of use case model generation. So in activity model, the same business rule means the control nodes, and as you know, in activity model, control nodes are different. It is initial, flow, final, decision, match, fork, and so on, join nodes. So it is very important to know which of them is a particular business rule in an enterprise model. So there are other behavioral models like UML state machine model, UML state protocol machine model, and there are business rules also different elements. So here we can understand that in enterprise model, in business rules element, we have all the information which is related to every UML model element which relates with business rule. And in sequence model, we have the same part that business rule element can be generated into, in this case, into 5 different sequence model elements by different meaning of them. So here we can say that with the help of enterprise model, we can choose which of the business rule elements can be generated in what UML sequence model element. And of course, timing model, the same story. We have 3 different elements which can be generated from the same business rule element in enterprise model. And in interaction overview model, we have 4 elements which also can be generated from enterprise model. So conclusions, yes, we know that enterprise model was defined, transformation algorithm I explained, business rule element variations I also presented, and the impact of these variations is also described because we, as I said, from the one enterprise model, from one business rule element, we can generate very different elements of UML diagrams, UML models. So the main idea of the research is that, in this case, that only high quality information which is stored in the enterprise model can help us to generate correct and truly right elements of UML models.
Okay.
So, thank you.
And one question.
Or it can be later. Because
No question. Okay, thank you. And the last presenter is Prima Gustiene.
Thank you very much. I am Prima Gustiene from Karlstad University, Sweden. And I also present my paper. I have little short time, but I'll try to make as short as possible. And of course it will be difficult because my paper is about modeling. So it always takes a lot of time to present. But this paper is about visualization and contribution to open access. 2 case studies were done, one at the Karlstad University, Sweden. Another was a part of our project at the University of Makerere in Uganda. And contribution to open access, but it is about, the paper is about how we visualize the process of publication, students' work publication, that is bachelor thesis, at databases in order to be transparent and reachable. So the agenda of my presentation will be, first of all, I'll talk shortly, everything now will be shortly. Goals of the paper, research methods used. I'll talk a little bit about the problems that we have with conventional modeling methods and why we need new ones after 50 years that we have modeling and use conceptual modeling. I'll talk a little bit about why modeling and integration, these two concepts are very important. I'll present a little bit our vision for open research data. And I'll talk about the DIVA is a portal or database where we put our publications and our research. And I'll present modeled versions of 2 case studies because I was using 2 different modeling methods and made the comparison and which method is better, what was the most important to see which modeling method has more semantic power to visualize the necessary aspects of the system. And I'll finish my presentation with the conclusions. So the goals of the paper was, first of all, it was a contribution to our open access policy that we have at Karlstad University. And it was one of the parts of our contribution, visualization of the process. I'll introduce different modeling methods that this visualization was made, and to show, as I said, and to motivate which modeling method has more semantic power, which was better to visualize this process, business process. So research methods used, it was 2 case study done and interviews were done both at the Karlstad University libraries and the department of our information system department, and as well interviews were done at the Makerere University. In Uganda, I also interviewed the representative of library and institution, also Department of Information Systems. 2 modeling methods are used. These 2 modeling methods we are using in teaching, and both are, so to say, to conciliate method is created at the company in Karlstad in Sweden, and semantically integrated conceptual modeling method is constructed also and built in Sweden. Maybe the beginning was in Kaunas Technological Institute, but I also, my research is a part of construction of this method. But you can read about that in references. So actually now very shortly, who is involved in modeling, they know these problems, that we still have the problems with traditional modeling methods. Why? Because existing traditional modeling methods do not integrate the 2 most important things in modeling, that is data and processes. They cannot go separately. That is the problem with UML. You will be, you didn't agree with me, but still, we have to have a model or method that provides us possibility to model and to show, to visualize in that way that the construct has possibility to integrate data, processes, interactions, and structural and behavioral aspects. Behavioral, it means that data changes, that changes of data that take place when some action take place. And of course, traditional modeling methods provides us a lot of diagrams, 13, 16, but how to reach integration is the problem. And of course, the last problem is that we have no modeling construct or model that shows us the process, how we go, how we analyze from goals to implementation. So modeling integration is very important because just modeling helps us to visualize, specify, construct, and document the structural and dynamic aspects of the system. Modeling is just the only way to control and to manage complexity, to detect the characteristics that we would like to avoid is discontinuity, discompleteness, and ambiguity. This is what we try and can do and overcome just with modeling. And of course, modeling helps us to see if we are doing the right thing and if we are doing the right thing right. Validation and verification. And integration. It's not enough just to analyze different aspects or different parts. Integration is very important. Synthesis, not just analysis. So what we are doing, or I'll show in this example, is of course it is about conceptual modeling, and what we need, the purpose of conceptual modeling is to provide, of course, a set of constructs, rules, and principles. So when we build some construct or method or methodology, it should provide these things in order to increase understanding of problem domain, to help analysis and design, and of course facilitate better communication, agreement, and learning process. Everything what we do for people. Usually we pay a lot of attention to IT implementation, but usually we have wrong implementation because analysis and design was not made correctly, or modeling was not used at all. We have to have a way to define the goal. Okay, it could be at the very high level as a text or some textual, but you know our natural language is very ambiguous. We have homonyms, synonyms, and actually the semantic problems of communication is one of the biggest problems between business people and IT people. It's a long, the old problem. So now Karlstad University vision is, has, an open research data to be one of the open university, and to be preserving knowledge and to be transparent, and to, so we have, the university have some policies that we have to follow concerning promoting open access. In last year, Swedish Research Council was appointed as a coordinator of the implementation of open access to research data, and it was especially in the National Library of Sweden and National Archives, and of course higher education institutions. It was important for them that all publications that we publish, that students publish, should be put somewhere where we can share, and that it should be transparent for others. And of course, Karlstad University took the part of this national network for open research data. DIVA is a portal or repository or database that we have in Sweden, and it is 47 different universities uses this DIVA portal or database where we put our publications, and students, when they finish, when they get the grade, they also publish. So now what we did this modeling of this publication process. So DIVA was developed in Uppsala University in Sweden in 2000, and of course now 47 different universities uses this DIVA repository. So visualization of publication, it's not enough to have the manual that we have. Of course we have manual with text, but we think that it's important to have a complementary visualization that it's always easier to understand because a picture is worth 1,000 words. So 2 cases were done, and first of all, this modeling case was done with to conciliate method that supports actually analysis and developing of the organization. And what is very good, that this method is applied and integrated in the tool. So our students are using at the A level this tool to generally to define the process modeling on the very high level of abstraction. But I think from my modeling point of view, I think that it's not enough, and I'll show and tell why. So I was remodeled the same process with our semantically integrated conceptual modeling method that we called SICM, and I'll tell also why. So the scenario of our publication process when the students get the grades is as following. We have 6 actors involved. We have supervisor, we have examiner, we have student, we have administrator, and we have 2 databases, DIVA and LADOC. LADOC is a database where we put all the student results. So actually when supervisor gets the final thesis from the student, he sets the grade and sends the final thesis to the examiner. It could be 2. When examiner evaluates the thesis, he sends the notification about the grade to the student and to the administrator to approve the thesis in registration in DIVA. But when the student gets the approved grade, he himself registers his thesis in DIVA. It is almost obligatory to do that. So then the DIVA sends the mail to administrator. It's a person who notifies about notifying the publication, and administrator approves the publication. He goes into the DIVA and looks, was it the correct version published, and then if the correct mark, and then he reports the grade into the LADOC. So actually it was 6 steps, and the procedure was as following. The sequence was as following. So now here you see in the corner, you see the legends. And here is the process modeled using to conciliate method. It is very linear online, and actors are attached to all the objects. DIVA or LADOC as a database could be seen as an actor or role as they define. So actually business object, it would be as a flow, application, they call this notation, actor, role, activity, and document that is going on. So actually, as you remember when I showed 6 steps, now if we count here, sorry, oh no. What happened now? sorry, we have no time enough. So it is attached, for instance, there is no interaction between actors. That is very important, because now you see that some processes are merged. This approved thesis is sent to the administrator. The action is not shown. So actually, we think that this way of modeling is not enough to understand what happens when some actors interact. It's very important because it has much to do with responsibility. So I think, and we thought that it's not enough, so we modeled the same process of publishing, first of all, at the Karlstad University, according to the same scenario, using our Sigma method. And I would like to say some words shortly about this method. Before, I was calling it service-oriented modeling method for the analysis and design. Why it is service? This word service, is nothing to do with service-oriented architecture, nothing to do with implementation, because I see service as an interaction. It is a dynamic process. So actually, this way of thinking, it's a new way of modeling based on interaction in this Sigma method. And we see every enterprise as a system composed of different subsystems that can interact, and they can play the role of service requester or service provider. So actually, we can analyze system using this interaction loop. Now we call it's a service. So the philosophy background of this, our method, is related a little bit to Bunge's philosophy. And he says that every subsystem, when subsystems interact, they cause changes in objects. And these objects should be manifested by properties. And it's really so, because every time action takes place, we have input and we have output. Action should do something to input, otherwise it is not purposeful. So actually, input and output is never the same. So actually, changes when the action takes place, to follow them, it's very important. So this way of thinking, that is, analysis could be based, or the construct could be constructed on the way of interaction as a service, I see, helps us to integrate internal or external behavior in one construct and integrate necessary architectural aspects just using one modeling notation or just one diagram instead of UMLs 13 or 16. So here are the construct what we are using. I am not talking, we have also 3-level framework, and we have the process and we have the language. So actually, through the goals analysis, we go to conceptual level here, and here we are using this construct. This construct was also built, it's not revolutionary, it's evolutionary. We take into consideration that service is very similar, or interaction is very similar to communication action. If you are familiar of communication action theory, there are two perspectives combines this communication action combines two perspectives. Intersubjective, between actors or between people or between software or hardware, and objective part. Objective part shows what happens to data when some action takes place. So actually this construct integrates data and processes, and that is what we would wanted to reach. So this construct was constructed, and now I'll show, it was just example, for instance, when you have how we show the difference between data, that for instance, applicant had the just attribute name and security number, but when he was employed, he got 2 other attributes. So we can follow and see. So, but here are the legend notation for Sigma method. So we have just at the conceptual level, we have actors, just boxes. Then we have action. We have different kind of flows. It could be information flow, it could be material flow, it could be emotional or whatever flow. But here we talk about this is information flow. Interaction and objects, and that is state transition. You know what is state transition. So actually now you see how we modeled, how I modeled the same cow thesis publication process. You remember all these 6 steps, what we done. So actually when supervisor gets the, here, oh, it's very difficult now to see, but you can follow interaction between actors, yes, intersubjective perspective, and at the same time you see changes in data. So it is not in linear, it is shows how interaction take place and what happens to data. For instance, of course, it is, as I said, it's not revolutionary. It is, for instance, UML. Experts know that it is, for instance, inheritance. Yes, that this is state transition. So there are similarities, of course, because we cannot make something new, very new, because people who are in modeling have to know. So actually, all these 6 steps were very clearly defined, and then we go to the last actor, it's Sladok, where Endeavor is here, and it is obligatory for our students to publish it themselves. Here it's, now it is, I did interviews, it is at the Makerere University in Uganda, and they told how they, so to say, the process of not publishing, because they also have database called DSpace, but it's not obligatory. There is actually no very big collaboration between library and the institutions. Library is very on the very high level of hierarchy. So actually they have 11 steps. And these steps involve different actors, not just supervisors. It's another process of thesis defense. So actually they have little bit research officers, they have graduate training research who sends everything in hard copy and soft copy to the library. But students themselves, they do not publish or something. They were very interested when I presented Karlstad University modeling. So I was modeled the same scenario, their scenario, using our method. And but the difference is that students send soft copy and final thesis hard copy to this actor, and then they send to the library. And do they publish or not? It's not really clear enough. But they were very interested because it was the project of open access, and it was just that this project was stopped, but it is because of political issues. And now I'll just to conclude very shortly that the goal of the paper was to show how the visualization of business process can contribute to open access policies. And open access policies, it depends upon the university, which policies they have, and of course how we can contribute and to make these policies more understandable, comprehensible for different people, different actors. And two different modeling methods were used for this process, and in order to show which we think from modeling point of view is better. And based on the results, we see that Sigma method has more advantages in comparison with to conciliate method. Because if we look at the problems that we have with traditional methods, Sigma construct provides us possibility to integrate data and processes, to follow interaction between different actors. And to conciliate method does not provide that. It is a linear, one way, is on the sequence, and it's very difficult to follow the interaction between different actors. That is important for some responsibilities to follow. So I think that it was enough. Quickly, thank you very much for your attention.
Thank you very much, and I would like to ask you questions co-presented in private after. Because we're leaving 50 minutes.
Maybe at the coffee break.
Already 50 minutes in the tutorial.
Vladimir is waiting for us impatiently, so.
No questions,
Yes.
but you can ask me later. I'll ask with pleasure.
I think it's important because you talk about classical modeling. There are so many different model approaches,
Yes.
like TOGAF, like
I know, but it's not enough.
And yeah, but I'm not sure. For me, it's not clear what is the difference of your new approach to all these high developed approaches.
Yeah, but integration, you
So
cannot
many-
follow
there are
integration.
So many modeling approaches now with a high maturity. And furthermore, for me, it's not clear how can you apply this model to enterprises, because you have an example from university, and in my understanding, it's very different from many applications in enterprises.
No, what do you mean enterprise? Enterprise, it could be organization, it could be any problem
Enterprise
domain.
is a profit-oriented company. That's not a university.
Yeah, but usually we model what we would like to do with information systems development, analysis and design to solve some problems. And then we can do problems that appear at the organization or enterprise. And all these traditional methods, as you saw or you can read, they do not provide that. Archimate, Dory, we have a lot of different. UML, we are teaching UML.
But yet we, may I interrupt, yet we have very modern modeling languages for business processes, let's say BPMN.
No, BPML is just for processes, not for data.
But yet we have some researches that have been done recently in this state that the most semantical richness could be reached, for example, by integrating the BPMN with the DDR. And
Okay. How? It would be very nice to see. It would be very nice to see.
This is another aspect of the process, but when I see, from my perspective, very complex graph.
It's not a complex, it's very, so to say, it's a basics.
Page 17, for example, it's very, for me, it's hard to comprehend.
Yeah, it is hard, it is a language you have to know.
Improve your skills.
Yeah,
because it's a language, you have to know the language. Do you know UML? Do you know?
At the very least, there should be some levels of abstraction and so on.
You know, I know this attitude. I am in research in many years. Just BPML, UML, and I am coming with a new.
Developed for a reason. Those are accepted standards.
Because these problems that I showed here with traditional modeling methods, which modeling method helps to solve them? Please, say to me.
Actually, we didn't see a method here as well, just notation.
No, wait a bit, it's just a short paper. You can read about the method. We have language.
Please stop the discussion because I have a lot of questions as well, and I
modeling is, we can talk all the day.
Discussion during dinner or I don't know, after tutorial,
I expected this because I know, I fight with UML and BML. Oh yeah, I know.
Actually, you should.
Thank you very much. Thank you for interesting presentation.
And all my thanks to others.
Thank you very much. Thank you.
Thank you.